Hello everyone, myself Maruthi, welcome you all to this math video session. In this video, I'm going to teach you regarding a quadratic equation word problem, right? So it's dealing with geometrical shapes. So the topic or the shape what I have taken is a right angle triangle. To explain you better, of course, before getting into the question, just let me recall few topics. Like in a right angle triangle, we have three sides and three angles. So if they want to play, we can play with the three unknown sides, right? But generally out of these three sides, any one side or any other relation will be given to us, right? And the relation between any two sides, either the hypotenuse or the base or the altitude, any such relations will be given in the question. So how it went on, let's check out the question now. The base of a triangle is 4 centimeters longer than its altitude. Here, he didn't talk about a right angle triangle. He didn't talk anything like that. But what are the two sides he is talking about? The base of a triangle is 4 centimeters longer than its altitude. Altitude, obviously, we take it as height. Obviously, altitude is nothing but height. And height will be always perpendicular to the base. That is the point what you have to remember. It is not mandatory that it should be a right angle triangle, right? If it is a right angle triangle, then the only thing what you have to think is nothing but Pythagorean theorem, all right? But it's not a right angle triangle, right? So we are not going to discuss regarding the right angle triangle, but it's just a right triangle. So in this triangle, he is talking about the relations between two sides. What are the two sides? Let's think on that one. The base of a triangle is 4 centimeters longer than its altitude. He is talking about the base and the altitude. As I said, altitude will be always 90 degrees to the base. Altitude, the line or the side which is perpendicular to the base, is nothing but the altitude. Okay, I will figure it out. Next, if the area of the triangle is 48 square centimeters, what is the number what he has given? He is talking about the area of the triangle. The area of the triangle is 48 square centimeters. Fine. Now what he is asking? Find its base and the altitude. Means he is asking us two things, right? What is its base and what is its altitude? To explain you better, let me go on with a figure for you. Right. It's not mandatory that it's a triangle. It's a right angle triangle. Therefore, 90 degrees I'm not drawing, right? But whatever it might be, we have to remember the space inside is nothing but the area. Right, the space inside is nothing but the area. Now, if you consider this side as the base, and right, if you want to take this side as altitude, obviously that side should be perpendicular to the base. If you consider this as the base, then if you want to take this as an altitude, that should be perpendicular to the base, means 90 degrees. Now, what is asking? He is asking us to give the relation. He is giving us the relation between the base and the altitude, and he is asking us to find what's the base and what's the altitude. Okay, but you have to remember the figure. What's the area he has given? He is talking about 48 square centimeters. That is the number he is talking about. Okay, that's the number what he is talking about. So to figure it out how it works on, let us go with the two relations what he has given. First thing, right, relation 1, that's the point 1, right? What is the relation? Here you have to remember there are two unknowns. Okay, when we are having two unknowns, obviously he should discuss about two relations, right? Two relations or two equations, so that we can figure it out, the two unknowns. Okay, but the first one we like to consider the relation he has given. The base of the triangle is 4 centimeters longer. So what's the word? By looking at the keyword longer, right, obviously you have to think it's nothing but plus, right? Something added, more. plus means you have to think the relation what he is talking about is plus. Right, with the help of the word longer and with the basic operation plus, we have to set up an equation between the two unknowns. How to set? I will let you know. That's the first concept. Now let's go to the second concept here, the relation 2. Why we are thinking about two relations means when we are having two things to find out, we have to frame two equations with the help of two equations what he has given. How to set up an equation? Search the keywords in the question and get it. So the first keyword what I am working on is nothing but longer. Longer means something more, means he is talking about some plus. So what is the plus between whom the longer thing is there? We will come back to that. And what is the second relation he is talking about is nothing but the area. Area is the second word what he is talking about. Let me come back to the keyword area here. Right, area. So whenever he is talking about area, what operation is involved? Is it something like addition, subtraction, multiplication, division? What kind of operation do we have? Is it? But whenever we are talking about these kind of operations, you have to remember addition and subtraction, they are like similar operations. Multiplication and division, they are of similar type. Okay, so if one is of addition, right, do we have the same addition here? Let us check it out. So what is the thing he is talking about? He is talking about area. What does the meaning of the area? The space inside. How to find the area of a triangle? You all know this one. Half into base into height. Now, as soon as you look at the formula, you have to figure out what's the operation. Do you think any plus or addition or subtraction going on there? No, the product is going on there, multiplication. So, if you check it out, we are having two relations. One relation is dealing with terms of plus, the basic operation plus, and the other relation is dealing with the basic operation multiplication. Are they of similar relations? No, no. So, forget about linear pair of equations. Think about only quadratic equations. That's the way to figure it out, whether the sum is a linear pair of equation or quadratic. Okay, yes, we got it, a quadratic. But the thing is, in quadratic, we have only one variable and the power should be raised to 2. That's a quadratic equation. Means, but how many unknowns are there? Two unknowns are there, but we'll be getting only one equation. So, what to do? What to do means, out of the two unknowns, you eliminate one of the unknown. What's the meaning of eliminating? Removing from the sum. How can you remove? Just by replacing. Instead of one variable, you place one more relation, one more variable basing upon the relation he has given. So I will let you know. So the first relation will be helpful for you for eliminating one of the variables. You have to remember this one, to eliminate. Right. We'll be using one of the relations to eliminate either of the variable. The next one, the other relation, which is nothing but the product, we use to raise the power to the 2, right? To raise the power to 2. Yes, you got it, man. So we are having two unknowns in a figure called triangle. We need to find base and altitude, which are two unknowns. Right, to find two unknowns, obviously we go with the two variables, right? But here, as we are dealing with two different type of relation, use the first relation, that is plus or something, and eliminate one of the variable, and use the second relation to raise the power to the square, right? With only one variable. So when one equation is there and one variable is there, solve it with the help of any quadratic factorization or any other method or a formula method, and figure it out what's the value of the x there. All right, so I'll be explaining it now with that one. Okay, so now whatever I have explained you in a logical way, let's go in a systematic step-by-step procedure. As I said to you, two relations. First relation with plus, second relation with product. First relation to eliminate one of the variables, second relation to raise the power to the 2. You have to remember this, and we have to figure it out as soon as you see the question basing upon the keywords. Okay, now as we is talking about a triangle, let me construct a triangle. I have taken a triangle ABC. He didn't say it is a right angle triangle, therefore straight away I didn't take it. But what he said, one of the side is the altitude. Right, I took the altitude like this, but altitude should be always perpendicular to the base. Therefore, I took the base and the altitude, then I said it is perpendicular. That's what he said. What he says. Now consider a triangle ABC. Yes, the base is this, altitude is this. Now, what is the base here? I like to take the side AB as the base. AB as the base. Okay, fine. Now, I like to take the altitude as BC. Very good. BC. Okay, but we have to make it as a variable. We have to take it as X or Y. Okay, which one should be taken as X and which one should be taken as Y? For that one, as we always deal with the logic, that is the one to which the comparison is done. Right, to which the comparison is done, that should be taken as X, and which is compared should be taken as Y. That is a beautiful logic. You are always supposed to remember that. Here, if you check it out, base of the triangle is 4 centimeters longer than its altitude. Base is compared to the altitude. Okay, you have to remember, base is compared to the altitude. Therefore, altitude should be taken as X. That's the point to be noted. Altitude should be taken as X here. Okay, so I'm taking it as X centimeters. Fine, fine. Now, which is compared? The base is compared to the altitude. When you have taken altitude as X, now consider the base as Y. Yes, I'm taking base as Y centimeters. Yes, right. We have introduced the two variables here. Fine, very good for that. Now, how many variables we have? We are having two variables here. So the base we are taking it as Y, and height we are taking it as X. Good, good. Now let's go with the question or the problem. But what I said, always take the sentence from the question, convert in terms of symbols. That's what he says. According to the problem, base is 4 centimeters longer than its altitude. Right. He has given a sentence we picked out from the question. How to convert that one in terms of symbols, right? Okay, what's the symbol? We have to use it for longer. That's it. I said you it's nothing but plus. Okay, now what is the symbol for is? It's nothing but equals. Fine. So now let's convert in terms of symbols now. What he says, base is, okay, 4 centimeters longer than the altitude. Fine. So base I have written, equals also you written. But you have to remember the second logic always. Order of sentence is opposite to the order of symbol. Right. This is an English sentence. 4 centimeters longer than altitude. Right. The number 4 is here. Altitude is here. Obviously, the longer is in between. Right. So, which is coming beginning? 4 centimeters. But when we are writing the order of symbols, it should go in the reverse order. The one what we have written at the beginning, you please write at the end. 4 plus, right, what's that one? Altitude. What's the altitude? Right, that's what you have to remember. Means base is 4 centimeters longer than altitude. We have reversed the symbol. That's the cool way which you have to remember. Certain things which we have to remember so that we can make the smooth flow of the sum. Now let's convert. This is the sentence we have converted in terms of symbol. Now you simplify it. Right. What is the meaning of simplifying? Plugging in the values what we know. So the base, what we took it as base as? We took the base as Y. Yes, Y equals altitude. What is the altitude variable? X plus 4. There we go. We are ready with an equation. Just now I said we are using the relation 1 to eliminate one of the variables. So what we got to know now? Wherever we are going to see the variable Y, you have to replace it with X plus 4. So with the help of equation variable first relation, we choose, right, what to be replaced for Y. Right, we are going to replace Y with X plus 4. You have to remember this one. I like to call it as equation 1.1. Okay, now let's come back to the second relation what he has given in the question. So what is the second relation he has given? He said, according to the problem, area is 48 square centimeters. Area is given it as a 48 square centimeters. Okay, now area he is talking about, right, area is equal to 48 square centimeters. This is what he has given. Okay, now let's convert that one. What is the meaning of area? Right, let's go from here. So what he says, area is equal to 48 square centimeters. This is what he has given. Right, now as I said, the sentence we have to convert in terms of symbols. Now you simplify that. Of course, we are writing the symbols for that. Area, as you all know, half into base into height or altitude, right? Half into base into altitude is nothing but 48 square centimeters. This is what. Okay, now after substituting the symbols, let's simplify that. How to simplify? It's nothing but by replacing with the values. That is half into, what's the base we took? We took the base as y times, what's the altitude we took? It's nothing but x. Okay, but don't forget the units of that. So it is nothing but x centimeters, and here also y centimeter equals 48 square centimeter. Okay, now if you simplify that, okay, what we got now? So if you check it out, it's nothing but now we got the values of x and y, but we know what is, how can we replace y with? We can replace y with x plus 4. Why? Because we are having two variables here, y centimeters and x centimeters. We don't want two variables. Why we don't want two variables means we are having only one is equal to. When we are having one equals, we can solve for only one variable. We can't solve for two variables. So, but we are having x and y. So, let's eliminate with one of the variables so that we get only one variable. How to eliminate? By using the relation y is equal to, in the place of y, replace it with x plus 4. Let's do that. Half into, right, x centimeters is equal to 48 square centimeters. Now, what's the value of y? It's nothing but x plus 4. Again, this also will become something like centimeter. Okay, now if you check it out, now let's simplify. Let's cross this one, the 2. Let's multiply to the other side. 2 times 48 is nothing but 96 square centimeter. Now here, x plus 4 times x. Now centimeter into centimeter, it also becomes square centimeter. Okay, now you cancel up these two. Now let's work on only the calculation part. Right, now distributed x square plus 4x is equal to 96. Now bring it to this side. So we are having x square plus 4x minus 96 is equal to 0. Now if you check it out, how many equations we have? 1. How many variables we have? Only 1. And as the degree is 2, we have reached a quadratic equation. Now to find the value of that x, obviously we use different methods. It might be a formula method, eliminating the splitting the middle term, or anything else. Now I like to use the same factorization or the elimination the middle term. For that one, you know the way to do that. So the quotient of, right, x square is 1. Multiply with 96. 1 into 96 will be getting 96. Now let's distribute that. 2 times, it's nothing but 48. Again, if you check it out, 2, it's 24. Again, if you go into 2, it's nothing but 12. Okay, now let's use all these factors. Right, 2 2's 4, 4 2's 8, and what is the other factor? It's nothing but 12. So 96 is the product of the A and the C. Right, I'm splitting that 96 in terms of the two factors 8 and 12. Of course, if you multiply 8 times 12, we'll get back the 96. Now, but you add them or subtract them, get the middle term. You add them or subtract them, get the middle term. So I'm choosing to subtract them. Therefore, but the middle one is having positive sign. keep that one to the bigger one and take the smaller one to the negative side to the smaller one. Obviously, it is becoming something like plus 4x, which is in the middle. So, with the help of these two factors, I am trying to split that. That is x squared, right, plus 4x, minus, it's nothing but minus 8x plus 12x minus 96 is equal to 0. This is how I am going to split that. Now, if you factorize that, if I take x as common, here out of x times x, if I remove one x, we will be having x minus, okay, if you remove this x, we are having 8. Now, out of these two numbers, we are having 12 here, and 96 can be written as 12 times 8. Means 8 is also present there. So what I am doing, I am taking plus 12 as common. Why? Because whatever sign we are having at the beginning, we have to take that. So if you take 12, the leftover is x minus, if you remove this 12, we are having 8 there. Okay, now if you check it out, we are having the factors x minus 8 and x minus 12, we got the same. So x minus 8 times x plus 12 equals 0. Now, right, by using the zero product property, we can say x minus 8 equals 0, or, right, what's the next one? X plus 12 equals 0. Right, what's that zero product property? You have to remember that one. That is, if a into b equals 0, which implies a equals 0 or b is equal to 0. This is called as zero product property. By using that, we are going to split this one in this way. Now, x is equal to 8 or x is equal to minus 12. We are getting two values here. Now, out of these two, which one shall we pick? Right, please remember here x is, what is x here? X is nothing but the altitude. Altitude means length or the measurement of a side. Can we have the measurement of a side as anything that's negative? No, we can't get the value. Right, we have to write that. We know that length can't be negative. So, as length can't be negative, I have eliminated x is equal to minus 12. Therefore, x is equal to 8 centimeters. What's that x? It's nothing but the altitude. Yes, it's nothing but the altitude. But that's not only the variable. We need to find out the other variable. What's that? Base. So, what's the base we are talking about? Base. Y equals x plus 4, right? So now y equals, what's the x value? It's nothing but 8 plus 4, which is nothing but 12 centimeters. We got the altitude and we got the base. Fine, we concluded. But until and unless we verify that, we can't say the question is or what we have done is correct. Let's go for verification. In that verification, you have to remember that one. The relation what we have chosen, we are having two relations. The addition wala the first relation and the area wala second one. Here if you check it out, we took the relation 1, right, to get the value of the altitude and the base, right? Therefore, use the other relation, which is nothing but the product, which is nothing but the area, right? Use the area concept and check it out whether the relation or the values what we got from the relation 1 are correct or wrong. So, what's the area he's talking about? Area, as we all know, it's nothing but half into base into height. So half into what is the base what we got? Base is nothing but 8 and the height is nothing but x, or it's nothing but 12. I think I have interchanged it. Now if you check it out, 6, it's nothing but, if you multiply that one, 6, right, it's nothing but 4 12s, it's nothing but 48 square centimeter. So, area we got it as 48 square centimeter. So, we have substituted the value of the base and height in the second relation to check whether what we got, the answers are correct or wrong or not. Hope you are able to understand with me. Thank you for watching the video. In this channel, I have been placing both math and science videos.